Hey, this is a test video on how to speak Python, where we'll try to deviate from the main flow of the course, just to give you guys a little bit more of scaffolding so that you don't feel lost if you feel lost. Anyways, let's firstly step back from even doing any coding and just recap the interface. Most of our interaction with Python was and will be happening through the Integrated Development and Learning Environment, or IDE, or IDLE. But if you're like already super proficient in Python, you could just drop the big L and just call it IDE. What is IDE? They could come in all different kinds of flavors. Sometimes they have lots of fancy stuff added to it. Sometimes they're slightly simple or somewhere in between. What's the purpose of IDE? It's just to provide you with a way to interact, write, run your Python code, or honestly, any programming language code. Sometimes it's just adds some additional functionality that is useful for really specific stakeholders. Some IDEs are targeted for a broader audience. Others are like, this one is only for data scientists. This one is also for only for scientists. However, in our CS 110, we're going to be using the IDE, uh, IDLE shell. So this is the most basic version of IDE that has nothing that we don't need, but it still runs exactly the same version of Python on the back end. And we just don't need to worry about all this bobs and whistles. There are two parts to our IDE. There is a text document with instructions, so where you are writing your Python program. Sometimes we're gonna call it script, program, file, all these words interchangeable, but this is basically just a text file. You could write your essay in the same version of a file and like submit it for a different class. Don't do that, but in reality that is possible. And there is shell. Also Python shell, Python console. That's where Python lives. That's where Python talks with a processor to execute your code, compiles it, run, gives you answers. So that's where it lives, where it's sort of like brains are stored. And our text documents are sometimes memory, sometimes just a short term memory. So if I create a really simple program called print hello and write it in my script called test.py, then run it, you could press F5 or just like click run, drop down menu, run module. The shell just gonna read all the instructions that you provided and will simply execute them and provide you results. That's simple. The next thing that I want to cover in this teeny tiny video is about functions. Functions are the tiny programs, and all the functions are structurally the same, where we start by defining the function with a certain name. It could be called my beautiful function, it could be called destroy the world. It doesn't matter. Just make sure that you remember this name and you could use it later. Then all the functions, they have some arguments. So inputs that we or parameters that we put inside of our function, and we could do something with them later. So those are our inputs. Then there is the body of function, basically all the programming that is happening within the body of a function. And at the end, we use a special keyword called return, where we're returning some sort of value. What's the result of our function? What's an output of our function? Yeah, we could take. Let's take a look at our really simple example where I've created a function called add that takes num1 integer, num2 integer. Then I'm using this define keyword basically to tell Python, hey, look, buddy, I'm creating a function, just don't be scared. And at the end of a function, I'm using return. So sort of I'm creating a frame for where my function exists. Then I'm creating a function name that I will be using later down the line. I called it add. It's in blue. Then I added what is called a docstring, basically a fancy way to describe what your function is doing. It's absolutely unnecessary to do that in some of the cases, but in the future, if you ever be working on really cool, large projects with like many people working together, collaborating, it might be a really good idea to explain what you're trying to do and what is happening, what it takes as an input, and what it takes or like returns as an output. Then we have our code or part of the main juice of our function, where we have a variable, one that we mentioned earlier. We have another variable, and we're creating a third variable called result that we will be returning later. Here, in our code part, I'm using the assign operator. Basically, since I'm creating this new variable called result, I need to tell Python, hey, buddy, that's new thing. Put everything that's on the right part of this equal sign into my result variable. And there is one more operator called addition operator, basically plus sign. In a sense, you could think of all these operators as some really teeny tiny functions, because they are. But since they're being reused so many times, it's not clear what are inputs, what are outputs in these teeny tiny functions. And they're like so basic, we're gonna call them operators. And there are some comments. So text that is not readable by Python. Python could not understand a single word that is written by after this pound or hash or comment sign. But those are just some really useful, sometimes, comments for us humans to interpret. And we could also use some built-in functions like print. We used it before. And in this example, I'm using my add function. I could just drop naming my inputs or parameters, or I could explicitly specify that, hey, please add 3 and 10, and my first number is 3, my second number is 10. Errors. What if some things are not going as planned? The main idea behind errors is that computers are stupid. And we as humans really good in recognizing patterns and figuring out what we're trying to accomplish, even if instructions are incomplete, wrong, or just not that clearly defined. Computers are not that great yet, so they're sometimes spitting out some errors. Imagine a situation where you were writing a simple program called grid. In everything that this program does, it says hello, and whoever it needs to grid, it says hello plus this name. Simple. What could go wrong? If I could run, if I would try to run that program, that would be the output or result of this program. Looks scary. That's an error. It's like red, and that's by design. by really poor design, but still, some thought process was put into designing this error message. Let's try to properly read this error message with an idea that if we could understand how to read this error message, it might be easier for us to read error messages in the future. So, we're going to be reading them from bottom to top. Yes, really human way to do stuff. And I highlighted different parts of error message to help us slice and scope how to read the error message. Firstly, we'll start with the exception name. It's Python category for type of where it thinks it misunderstands you. For example, here it uses the exception called name error, which is not that human readable on its own, but that's just a category, and we could try to induct what does it mean. So like something wrong with the name. What is name? Maybe it's like a variable. Maybe it's the name of our function. Still not exact information, but it puts us into like mindset of what we're going to be looking for. Then, after our exception name or sort of error name, we will get the actual error message. The most humanly readable message that Python will give us, it says that name sum on is not defined. I don't remember using any words called sum on, so let's take a look back at our code, and we'll see that even if in my parameters I defined the word called sum1, I made a typo, and where in the body of my function, where I was using the print, I missed the letter E, and sum1 turned into sum1, which is somewhat embarrassing error to make. How could I, HE for a class at Northwestern, make such a silly error? That's just unacceptable. However, in reality, typos are one of the most common mistakes that programmers do. This is an example of an article from 2018 about the computer game called Alien that was notorious for its terrible artificial intelligence of the alien in the game. Turns out one of the developers just made a typo somewhere in a game, millions of lines of a code, and they weren't able to catch it in time, so the game was released as it. Long story short, everyone makes mistakes. You will keep making mistakes now, like in 10 years, if you are gonna be programming in the future. There's nothing wrong with that. It's actually something wrong with Python. It could have gone way better in recognizing the way how humans are using it. But yeah, we'll have to deal with it. And finally, there are part of that is called a function call. Basically, it's just trying to tell you where exactly it's Python encountered an error. Again, it goes from top to bottom, top the most recent call, bottom the least recent call. What does it mean? So the line that's second to last, it's trying to tell us that file, our script, our program, where in our file. So here it says line 2, and line 2 is where we have our print hello plus someone. It's not putting it in a really human readable way, but still, it gives us enough hints so we are, we as a really smart humans could figure out, hey, something on line 2. Let me try to take a look at it. Maybe I will figure out what's wrong with it. And speaking of exception names, yeah, there are some attribute errors where we're trying to use some attributes that don't exist for specific variables or objects. Uh, there could be some import errors when we're trying to use a library or a package that maybe doesn't exist. There are some obviously common syntax errors where we're maybe missing a comma, maybe missing a semicolon, maybe a dot, something there. Sometimes Python even like tries to put a literal error where it would expect a certain syntax. So that's also a hint for us. Okay, that was a test short video where we learned that Python has different parts of the interface, that functions have multiple parts. All, even the most complicated functions are almost structurally the same to the easiest, the simplest functions. Errors are fine, and there is no need to be scared by them. And maybe as a bonus learning outcome, if you are excited about learning more about Python, added a link to what is called fstrings. That is a slightly fancier way of writing string statements. Uh, I'm not gonna go into any details about what exactly they're doing, but if you're interested, if you're curious, that is something for you to check out. See you. How do I stop this video? Please.